So, hello candidates. Very good evening. This side Ankit, and let's just continue with the today's topic, right? So, I'm sharing my screen, and I hope I'm audible to everyone. And with I have already shared my screen, so just let me know my screen and my voice should be audible, right? Is my screen is visible and is my voice is audible? Just let me know, candidates. Okay. Okay, so guys, in the last class, we have just already completed this topic, and that was all about the overfitting concept, underfitting concept, and the boosting technique, right? Yesterday, we just completed the regularization technique. We know that we have three different set of regularization. The first one is called the L1 regularization. Second is like L2 regularization, and third one is called the elastic net. Elastic net is nothing, just a combination of both L1 and L2 technique, right? Why we want to use this regularization technique? So that we want to minimize the overfitting issue, right? We simply call this data set. The data set was related to the Canada per income data set, right? So the last topic that we have just performed is to import all the models and to create the list of all model, right? So today what we are going to understand, we'll just run the for loop over this model. We'll create a model, and followed by each and individual model, we'll try to calculate the overall prediction value and the score, and which model is getting the highest score or like the best accuracy, then we will finally select that model, right? So let me just quickly run all the codes, right? We know that all these are part of ensemble technique, and inside ensemble technique we can simply call multiple models. The first one is like the random forest for the bagging concept, and for the boosting concept we can use ADA boosting, cat boosting, XG boosting, LightGBM boosting machine, and so on, right? The first one, which is the gradient boosting. So let me just quickly run all the codes. Okay, now what you have to do, you can take a reference of this notebook. I have already shared this notebook with all of you guys. Let me just share it again. Okay, so you can do the practice parallelly. And this is the next topic that we are going to cover. Okay, so now let's just import all the modules. Let me quickly run this code file sample X and Y. Okay, and now I'll call all the models. From sklearn, we have imported the gradient boosting regressor and the gradient boosting classifier. But the problem is related to the regression problem. So we are not going to use this gradient boosting classifier, right? The second boosting that we have used is ADA boosting. ADA boosting, we know that it's nothing, just adaptive boosting, where the learning rate or like the weights is adjusted automatically, right? If we want to use the LightGBM, it's also a part of boosting mechanism, but we cannot directly use it. So we have to install this LightGBM, right? And you know that LightGBM or like LightGBM is mainly designed for the large data set or like the complex data set where the velocity of the data set is very huge. Then we generally prefer this as a LightGBM, right? So let's just call this LightGBM regressor. And if you want to use the XGBoost, so I need to use the XGBoost right now, because the problem is XGBoost generally we refer when we getting the categorical data. But the problem right now is completely based on the numerical one. So we are not going to use this XGBoost regressor. What is the use of XGBoost regressor? We have already understand this. The XGBoost generally used when we have a categorical data and we want to convert the categorical data into the numerical one. We have to follow the period of get dummies or one hot encoding. But in case if we don't want to perform the same step, then we can use this XGBoost. It by default perform the one hot encoding or like data pre-processing. Okay, so let's just finally call this all model. Now what we are going to understand, candidate, we'll just simply do one thing. Let's just call the train test split. Simply give your X and Y data set. You can call your random state like here. And it is 42. And you can just keep the test size as 0.2. It's like the 22, like 20% sort of. Okay. Now, instead of directly running this, we want to individually split data set again and again with the help of for loop, right? So that we can train some parameters as well, or like hyperparameter. So what I do for I in is range, and let me just create my model with 20 iteration, right? In this 20 iteration, I'm training and testing my data set again and again 20 times. And instead of random state 42, I'll just simply call my random state as I. And I know that I will become the each and individual random state, right? Now, after converting the data set into train test split, we know that we'll simply get the unpacking of this data set, X train and X test, Y train and Y test, right? Let's just quickly unpack this data set. And once you unpack this data set, now what you have to do, candidate, you have to again run the for loop over this all model, so that you can create your additional model for each and individual test value. And you have to check the accuracy or like the prediction score of each and individual model. So let's just run this for loop for J in all model. Okay, you have to call your model, and you know that your model is simply refer by this J value. So J is like your each individual model. The first model that we are going to get is linear regression, second is lasso, third is ridge, and then fourth AdaBoost, fifth one XGB, and sixth is gradient boosting, and third one is elastic net, right? Now what you can do, you can just simply, okay, I think I'm not using the LightGBM right now. Okay, so let's just call the LightGBM also. LightGBM regression, not the linear one. LGBM regressor, right? Okay. Now let's just run this again. So we are going to get almost 1, 2, 3, or like 7 to 8 of the ML model, right? So we are getting this ML model with the help of J iteration value, right? Now we know that we have to simply fit our model using the fit method. It's like we are training a data set. So let's just simply pass this X train and Y train, where you can simply train your data set, right? Like this, okay? Once you train your data set, what you have to do, you have to check the prediction value for the Y test, right? And in that case, you have to give the X test, and this will give you the Y predicted value. And guys, you are already familiar with that. Once you get this Y predicted value, you have to calculate the score, and the score you can simply calculate this with the help of Y test and Y predicted, or X test, and you have to give the Y test, and this is your the model score. So let me just store this inside the score variable, right? Now, what we are going to understand, we'll create a dictionary. That dictionary is responsible to store all the iteration data. So let's just consider this as a master data, where we are going to store each and individual iterations value, right? So the ith value is simply given by the random state. The first iteration is like 0, so the random state will be like 0. If the random state is 0, it will try to run all the model with the 0 random state, and then we'll check the best model with their accuracy or like score value, right? Now, once you get this score, you know that you have to calculate the errors, right? And you are already familiar with 3 types of error. The first one is mean absolute error. Second one is mean like squared error, and then followed by the root mean squared error. So inside this mean absolute error, you are already aware with that you have to give the Y true and the Y predicted value. So the Y true is like the Y test, and Y pred is some sort of like this Y pred. This will be stored inside this MAE. Now let's just again calculate the MSE. So let me copy this. You can just simply call this MSE, and instead of this absolute error, let's simply call this squared error, right? Mean squared error, right? And what about the RMSE? RMSE is just nothing. It's a square root of your mean absolute, like mean squared error. So you can just manually calculate this RMSE, right? Now, candidate, we have calculated all MAE errors, MSE error, and RMSE error. We have also calculated these scores as well. Now, what we want to append or like store all this data inside this master data. So let's just do one thing. Simply, I'll create a one. See, this is the final approach that you have to use in your day-to-day work, like in industry. You have to train your model multiple times to perform which iteration or like which random state or like which hyperparameter tuning is performing the best, right? So let me just create a key is like random state. It's responsible to store each and every random state of the given iterations, right? Then followed by the score value, model score value. Let me just create a key like model score, and this is responsible to store all the score. and then followed by their multiple errors. The first error is like mean absolute error, second is like mean squared error, and the third one you already know that is RMSE, root mean squared error. Now in this dictionary or like this master data, whatever the value that we are getting while running this loop, for loop, right? So we'll try to store each and every data inside this master data, so that once we got this master data now, then we can probably compare which model is performing best, right? Okay, there might be chances we can get the error right inside linear regression, lasso regression, because this LGBM regressor generally takes the decision tree or like the number of trees or like the splits. So we'll simply run this. If we get an error, then we'll try to cover up this, right? So let's just first run this. Now, how to simply get this value and how to simply store this value inside this master data set, right? So you know that the master data set is stored in a form of master data set. Now just simply call this key. The random state is the key. And inside this random state, what you want to store? You want to store your random state value. And you know that the by default random state value is the I. If the I will change, the random state will also change, right? What about the model score? Let's just copy this. And instead of random state, this time you have to give the model score, right? Model score, and make sure guys the key must be same, because Python is case sensitive, right? And inside this score candidate, what you want, you have to store the score value. And same followed the same step with the MA, MSE and the RMSE, right? So let's just call this master data set, master data, and I'll just simply call my MAE, and I'll try to append my model MAE inside all master MAE, right? And same, repeat the same step with MSE. Let's just quickly append MSE here. And the final one is like RMSE, root mean squared error. And you can just simply append your RMSE also, right? Once you appended all the data set, this master data, we need to convert this into the data frame. And we have a function which is the pd.dataframe, right? We can simply convert this master data into the comparable DF, right? Now, let me just first run this. There might be chances we'll get the error, right? Okay. So how to know that which model is running, right? So you can just say, just simply call this all model, create a copy of this all model, right? And it is like model names, and you'll just simply paste the same model. And we are just going to apply the code so that all model converted into the string, because we want to just get the name, like which model is particularly training right now my data set, right? So we are doing it manually, although we can run the list comprehension loop here, right? If we are getting multiple models now, so we can do this manually, like using the list comprehension technique, right? So let me just do this manually right now. Okay, candidate. Now we have all models named here. What we want, we are running this J loop, right? So if we are running this J loop, now the first model that we will get is the linear regression. So I want to show the print message that linear regression is running, or like training linear regression. I want to show that kind of message, right? So how to show this one? So you have to use the enumerate function. So what exactly this enumerate will try to perform? So enumerate is like, it will try to fetch the values as well as the index, right? So you can just simply store the index as well. This technique again is the unpacking technique. And we know that the first index is like the 0 index, then followed by 1 index, 2 index, second, fourth, and so on, right? So inside this for loop, we can just simply say this model training using model names, and we know that the model name is something like this, and we can simply subscript our data, it's like index, right? And once we run this now, guys, we'll get something like this one. Let me just show this. Okay, so it's like model training. Here you are getting the data. Can it just look at this? Okay, so we are getting some sort of infinite issue. Let me just show check this, what exactly this is. Okay, so we are getting model training using linear regression, perfect model training using lasso, ridge, AdaBoost, regressor, gradient, elastic, and LGBM regressor. But we are getting, there are no meaningful feature which satisfy the provided configuration. So what exactly the error that we are getting? It's based on the LGBM number of splits, right? So you have to decide the number of splits. So now how to do this? You can just simply say inside this, if my model index name, let me just run this. If my model index name is equals to LGBM regressor, if my model index name is like, if the model name is LGBM regressor, then you have to pass the number of split, because this is explicit parameter that you have to perform, right? So I'm writing this, if my model name is something this, so I cannot simply run my model like this, okay? So you can just say, in this scenario, you have to create the model J, but this J model should be followed by the number of splits, right? Let me just show this, what exactly. This is like the number of splits. It's like the n estimator or like n leaves. So you can just simply pass this as, let me just show this, LGBM regressor n estimator. You have to give this one, right? And the by default value is, let me just copy this n estimator. The n estimator is by default 100. Okay. So number of leaves that we are getting is the 31. Okay, the sample that we are also getting some sort of like this. All these are my hyperparameter values, right? So let me just call this an estimator or number of leaves. See, number of leaves is already by default now, but let me just quickly run this, and you'll just pass an estimator as 100, right? If we are getting the LGBM now, so we can simply turn this, and if the model is not LGBM, so the model will remain same ideally, right? Okay, and now let's just also import the time, so that it will try to say the model is running, and if it is performed well, so let's just call this time dot slip, and let me take this as 4 seconds, right? So it will take some time, and now it's saying model training using linear regression. After 4 seconds, it say model training using lasso regression. Then again followed by ridge regression. We are training the model multiple times, candidate, right? Model training using AdaBoost regressor. So instead of calling one model, we are training model with a multi approach, right? And that makes the final approach. If we are getting any data set, we are not generally relying on the simple model generation. We have to perform multi-model approach, right? Okay, so no more sleeves that me see model training using linear regression, model training using lasso. Why we are getting again the same thing? Okay, let me just check this. LightGBM stop training because there is no split, right? So we have to give the split. Split is like the number of trees or like the split that we generally give. Let me just check the value. Okay. The minimum leaves that we are getting is some sort of, go to this parameter. Okay. Where is the number of split, right? We have to give this argument, right? The by default split is the by default split. Yes, we are getting this value. So the by default split is like, let me just go to this one, and let's just take the help. Why we are getting this in the number of split, right? So we have to give the split requirement, right? It is the by default parameter that we have to give. Okay, so you have to give candidate like this, the minimum data in the leaf. We have to make this value lower, or like we have to increase the number of leaves as well, right? Increase if it is too well. Let me just copy this, and because otherwise this model try to run again and again, right? That is the reason we are getting this. Okay, quickly stop this, and instead of this n estimator, go to this number of leaves. Okay, now let's just run this. Okay, once the model training is done, then we can simply compare our model with the same sort of like different uh, approaches, right? Let's just wait for some time. So this time the model is training using the gradient boosting elastic net. Okay, and still we are getting the stop training because there are no more leaves that meet the split requirement. Let me just check what is the issue with this one. Okay. We just give this code and getting error during iteration, and the code is like this one. Okay. The LightGBM warning you posted earlier, error, it was the number of leaves, something this. Okay, minimum data in the leaf, right? See, we have to give this split, right? Minimum data in the leaf. Let me just call this minimum data in the leaf, right? Number of leaves and minimum data in the leaf. Okay, instead of manually slipping, let's just turn off this. Okay, no, we are getting the infinite value. Na? Again, this is a problem, right? Still working, I think. Let me just check. Minimum gain to split is something this. Okay, now what about this verbose? Verbose is for hide the warning, right? So whatever the warnings that we are getting, this is the warnings, right? We have to hide this warning. These are the hyperparameter tunings, right? We just take the reference of this. We are getting the model again and again multiple times, right? See, it's like, let me just check this. Number of leaves is equals to 31 and minimum data in the leaf is like 5. Minimum gain to split is like 0. Verbose is equals to this one. And let me just turn this value to 20 and minimum data in the leaf is like, let's just make this as 1. Minimum data in the leaf and minimum gain value to 0, right? So it will try to, okay. So there is no issue, right? Yes, it's performing well, right? Why we are getting multiple model again and again, guys? Because just look at this, right? The problem is like we are using the nested loop, right? This loop will try to run 20 times, and in each iteration we are creating the model again and again. So if we are having like, let me just check the length of this first. The length of all model is 8 and it's like 20 into 8, so we are running the 8 into 20, it's like 160 of the iteration. That is the reason we are getting multiple values again and again, right? And finally you will get the values as like done, and let's just call the master data, and you have to convert this master data into the data frame format. These are the matrices, right? So how you can simply turn out this to data frame? Simply call this data frame, right? Give this master data and you have to store this inside the compare model df, right? And then you have to select the final model, right? Now just look at this, right? Candidate, we are getting the compare model and each random state from 0 to 19. We are getting model score 76, 76, 97, 84, 96, so and so on, right? MA error, MSE error, and RMSE error. Now what we want, we are getting 160 of the rows. Why we are getting 160? Because 20 into 8 is close, like direct answer is 160. That is the reason we are getting this, right? So now let's just calculate the highest value where we are getting the model.score as the highest one, right? So now just go to this compare df, and inside this compare df you have to call this model score and just simply check the maximum value. What is the maximum score that you are getting? It's like 98%. And let's just do the unmasking technique or like the masking technique, right? So this is the maximum score that you are getting. So quickly store this inside this variable maximum score. Now we want to get the rows where we are getting this maximum score. So you can simply compare this with the max score value, right? And this technique is called the masking technique, right? This will give you the data frame where we are getting the maximum score, right? So we are getting maximum score at the random state 8 candidate, right? Now the best part is if you want to increase the iteration, right? So you can just do this. You can just increase the value is like like 100 of the iteration. So it's like 8 into 100. It's like 800 of the iteration that we will get, right? And it will take time. So let's just clear the output, whatever the output that we are getting. And you can use this method, which is called the display function, right? Display will try to clear out all the result output, whatever that we are getting, right? Now in this time we are getting or we are training model multiple times. It's like 800 of the model that we are training, right? That is the reason it costs you huge amount of GPUs or like the RAM if you are training very complex data set on multi-model approach, right? So let's just run this. And now we will finally get the data frame of 800 rows because we have created 800 different models, right? And each model is comparatively tuned by their different hyperparameter tuning. Now, if you just run this now, you will get the 800 rows, right? And you will get the each individual iterations and then followed by their scores, right? If you just run this, so you are getting 99% of model score. And just look at this, right? The MA value, MSE value, and the RMSE value. The MA value is very close, right? Very lowest. You can just check. Here, the 69% MA value is close to 2298, right? And now just look at this, right? So can it at this random state 26? We are getting the model with the highest accuracy. Okay. Now the problem with this code is now which model is particularly giving this accuracy? Are we getting the model name also? No, we are not getting the model name. So what we can do in this particularly dictionary, na, let's just also append the model name as well, right? I'll create my model name as a dictionary, and inside this, let's just append the model name. And where we are getting the model name is some sort of like this model index name. So let me copy this. Just go to this master data and call this model name inside f string. This is the model name, right? The model name, you have to call this as model name. You have to give the key, right? Model name, and inside this append this value model name slash index or like a subscript index, right? Now it will run all the iteration. It will create the multi-model approach, and then you will finally get which model is giving you this level of accuracy, right? Now let me run this quickly and just wait for this and just wait for this candidate. Okay, is there any doubt related to this? Anyone? Vijay, Spurti, other candidates, guys, is there any doubt? Just let me know in the message area. Are you getting the point now? How we are just training the model multiple times and we are creating the master data. The master data is responsible to store all each and individual's value where we are storing and training the model, right? And once we get this now, we will get the final compare DF, and that is 800 of the rows, and we are getting the 26th random state value. The model score is 99%, and MA is very less. MSE is also less. RMSE is also less, and the model name is XGB regressor. Guys, are you getting my point now? In this way, you can identify the model. And once you got this model now you can finally pick this model for the final prediction. And how to pick this model? If you want to store the model as well, so you can store the model as well, right? Again, you have to go to this dictionary. You have to store this as model as a key. And if you want to store the model now, so let's just again change this dictionary to master data followed by their model, and inside this you have to append the model, live model, so that you can use that model, right? Now let me run this fast, and now I can use the model for my final prediction. Okay, we are creating 800 models multiple times, and each model is responsible for their individual prediction, but we are considering the model which giving the highest score and less value or like less errors, whether it is MAE error, MSE error, and the RMSE errors, right? Let's just wait for a while. We'll get the final model, and the final model is the candidate. See, we are getting the multiple models. Now, these are called the data frames, right? And this is the model that you can use. Now, how to use this model for the prediction, right? You know that the index value is the 212. So just go to this compare model DF, okay? And inside this, use the ilog concept. Ilog is like, I'll use my all row and I'll use my last column. And this is the model, right? And the last column, I'll use my first value, right? So instead of all rows, now let's just call this as, okay, see, I want the 212 value now. So instead of 0, you have to give the 212 index, right? And this is the XGB model that you are getting, candidate. Now you can store this XGB model as your final model. Let me just quickly store this as my final model. And how we can store this with the help of file handling? This is your final model, candidate, right? Now, if someone wants to store this final model, they need to perform some file handling technique. So how to serialize this model? There is an interview point of view important question. What do you understand by serialization and deserialization, right? So serialization is like, it's a technique where we can store data using file handling, right? And that object is responsible to predict the values or whatever the model that is created for, right? So how to serialize the object? You have to import this module, and the name of that module is called Pickle module. Okay, candidate, we have three different methods to save this ML model. The first method is called the Pickle concept. Second, you can use the job lib concept if you want to store the ML model with the help of file handling. Let me just show this. Import job lib. Job lib is also responsible to save your ML model, right, inside your environment. And the third, you can use the sklearn approach also, right? Sklearn save model. Okay, this sklearn also give you the method to save your ML model, but the recommended is the Pickle one. Pickle one is the easiest one, right? So what you can do, you have to import this module and then followed by the file handling code, and with the help of with concept, which is nothing, just a context manager. Now what you want to save your ML model now. So let's just save my ML model as P per capita income prediction. Now the model is per capita income, so let's just name this as chat GPT per capita. It is responsible for prediction of per capita. Okay, and because you are using this file handling, so you have to give the extension as PKL. PKL is like the Pickle extension. Okay, and this file handling exactly needs the binary file, so you have to give the write in binary mode. And let's just quickly use the file handler object. And what you can do, you can use the f.write method where you can just simply write all your bytes code. Now we know that the bytes code are like, you have to, instead of f.write now, you have to use the pickle.dump, right? Use this pickle and then use this dump method. And inside this dump method, the first thing that it will ask you for the object, that which object you wants to dump. The object is like, we are dumping the final model, and with the help of f is like the file handler. And once you do this, then you can simply run this model saved successfully. Now the best part of this now, instead of training, like we have trained our model multiple times, right? Now you're not allowed to use all these steps again and again. You're not allowed to repeat all the steps again and again. That is the reason we are just creating the brain. And now this brain is simply stored in a form of pickle format. Now, if you want to predict any value, you're not like particularly required to write all code from scratch. You can simply call this module or like this pickle file, and with the help of this pickle file, you can simply predict the values, right? Let me just show this how to, instead of writing all code again and again, you can just simply download this first pickle file. Let me just download this, right? Even you can do this, right? Okay. And if someone is downloaded this pickle file now, then what they can do, they can simply use the file handling again concept with open and simply pass the file name as like this one. And instead of writing binary, now this time you have to use this as read in binary, and then followed by the file handler, and then simply call this pickle. And instead of dump, you will use the load method. Inside this load, you just have to give the file handler, right? And simply store this model as a like GPT. Like GPT. We are just simply referring this model as a GPT. Now this GPT is responsible for the per capita prediction, right? Let me quickly run this. If I'll get final done here, now I can use this GPT for my per capita income prediction. Let me show you how to do this. So GPT dot, you will directly get this method, which is called the predict method. And inside this predict, you can just simply give the value or like which year you want to predict the per capita for. If you just run this, you are getting the value like this in an array format. Let me quickly slice this value and insert and store this data inside the answer variable, right? Or you can assign the value inside this answer variable. And the final answer something like this. If you want to make it round, you can use the round function. And let me just quickly round it up to 2 decimal place. And the predicted per capita for year, you can use the F-string technique for the year value, and you can get the year answer from the input, right? Input is like 2016 or 2027. And let me just write this instead of year. I'll use my, like, instead of writing it manually, now I'll use my year variable, right? And it will give you the final answer like this. Okay. So the predicted per capita for year 2027 is, and you can pass out this answer. This is the answer that you are getting, right? So in this way, candidate, you can create your model. But why we are not getting the rounded value? We are still getting the value some sort of like this. Okay. Let me just first remove this, right? And let's just check whether it is working directly or not. Yeah. First of all, it is working. Fine. Now let's just make it round and keep the two decimal places. It's still not working. So let's just keep it right for now, right? So candidate, in this way, we have created this function or like this code where you have to give the value, and this model is responsible for prediction of per capita income for the given year. But the best part is we are not allowed to use the rest model concept. What we are going to use, we are just simply using the pickle concept. We have simply dumped our model, or like in short, we have saved our model. That model is nothing, it's just a live brain, and you can call that live brain and you can predict the value with that model. And the best part is you can also predict the same thing, right? Let me just upload this inside my GitHub account so that you can use it parallelly as well, right? So I'll just simply upload this. That chat GPT, where is the chat GPT one? Chat GPT per capita.pkl, right? If you want to use this, now you can use this from my GitHub account as well, right? I hope everyone has like my GitHub account. If you want to use it, just go to this and simply click on this. Where is the GPT per capita pickle? And now if you open this now, you'll get this option download here. Then simply click on this download raw file, right? Okay, candidate. So in this way, we can create a model, and that model is responsible for prediction of the value. And now the best part is we have to use the multi-model approach. And just look at this, right? Instead of simply relying on one model, now, guys, we have created the bunch of model. And here you can simply check this now. Guys, are you getting my point? Candidate, just let me know in the message area. Viva Lakshmi, rest candidates, Taruna, Sneha, Spurti. Guys, are you getting my point? So instead of just relying on one model, we have created a bunch of model, and we are just finally selecting the model based on their parameter, right? Whatever the matrices we are getting the best, we are picking that model, and we are saving that model with the help of pickle concept. The pickle concept is generally refer this as a serialization in the Python, and that is this one is important for the interview point of view as well, right? If someone wants to use this model, so instead of creating this model from scratch, they can directly load that model using the pickle concept, right? So candidate, in this way, we can use the multi-model concept. I hope everything is clear with this concept, right? Now, let's just focus on the unsupervised learning. Whatever the model that we have created, not only this one, right? See, these are like for the regression problem. You can refer this for the classification as well. Now, just imagine if you want to call the classification data set, you can have multiple models, right? You can call multiple classification ML model. And let me just show this quickly. You can simply go to this from sklearn and dot ensemble. And inside this ensemble, you can call gradient boosting classifier, right? Then AdaBoosting classifier, and then followed by the LGBM. LGBM is the regressor, right? Let's just call this as gradient boosting and AdaBoosting, and from LightGBM, you can call your LGBM classifier, right? Then from XGBoost, you can call your XGB classifier as well, right? Like this one, XGB classifier. So we have multiple classifiers as well. Now we can use the random forest classifier as well. So let's just use the random forest because this is also the part of this ensemble technique. From instead of directly calling this as a from, now let's just use the from sklearn dot linear model. We can use the logistic regression as well, right? So from sklearn dot linear model import logistic regression. You can use this logistic regression, not the regression. We want the classification now. So this classification is the regression one. We already know that, right? So from sklearn dot tree, you can use the decision tree. These are the model for the classification as well. Decision tree classifier. From sklearn dot naive Bayes, you can use the Gaussian distribution, right? Or multinomial distribution, okay, something like this, and the binomial distribution as well, right? The Bernoulli distribution, okay. These are the classifier that you can simply use, and I hope you are already familiar with this one. From sklearn dot neighbors, neighbors is like you can use the k nearest neighbor, and it is like the k nearest neighbor classifier, or like the regression you can use. So now just look at this candidate. Gradient boosting first, ADA boosting second, random forest third, LightGBM 4, XGB fifth, logistic sixth, decision tree 7, 8th, 9th, 10th, all three are from like naive Bayes, and 11th one is like the KNN classifier, right? Now just look at this. We have some sort of more than 10 plus model if you want to perform any sort of classification problem. So whatever the steps that we have applied in the regression part one, you have to apply the same concept for the classification also. Whatever data set that you are getting, on today onwards, you are not going to simply use a one single model approach candidate. Just simply understand one this thing, right? You have to use the multi-model approach so that you can just simply compare each and individual model and simply call out the best model that matching with your actual predictions, right? Okay, so in this way, we can call the multi-model concept, right? So these are the models that generally known for their supervised learning. Now, everyone already aware that we have mainly two different set of classification for the ML. The first one is for the supervised machine learning, and second one is for the unsupervised machine learning. Although we have reinforcement learning or like semi-supervised also, but the major broader classification is like for the supervised learning, and second is for the unsupervised learning. Now, what exactly the problem with the supervised and the unsupervised? Like why we want unsupervised if we are already having the supervised machine learning? Let's just quickly understand this, okay? Suppose we are getting this data set where we don't have the Y data set or like the Y target. Whatever the data set that we are getting is like for the X data set, or like the features. We have only the features, but we don't have any target. So if we don't have any label data set, then that problem generally falls under unsupervised machine learning, okay? Unsupervised machine learning. In supervised machine learning, you have both X and Y data set. And we refer X and Y data set is like label data set, okay? A labeled data set is like we already know that based on what features, what we are going to get as in terms of output, right? This is called by supervised learning. And here you can see that now we generally divide our data into training and testing part. And we know that X train, X test, Y train, and Y test, because we know that we have the Y part also. That is the part of this supervised machine learning. But what about the unsupervised machine learning? In unsupervised machine learning, we don't have Y target. We have to create our own target. We don't have the like actual given target, okay? We don't have the Y target, and there is no label data set, right? What we just get, we are only get, or we only get data set with features, not with the target, right? Not with the target. So you can just simply understand one thing. If you are getting any data set that doesn't contain any target, that generally falls under unsupervised machine learning, okay? But if you're getting the data set that they have both features and the target, so you can just refer that as the supervised machine learning. In the most of the scenario, you will work on the supervised machine learning. But we have some different scenarios as well where we are generally using the unsupervised machine learning, like the market basket analysis, okay? In the market basket analysis, we want to customize, or we want to segment our customers based on their spending score, right? based on their spending score. We also refer this as a customer segmentation, right? Okay, customer segmentation. We also refer this as a sentiment analysis or like movie sentiment analysis, but inside the sentiment analysis we have the sentiment like positive and the negative sentiment, so that will comes under the part of supervised machine learning. But if we want the recommendation kind of something, unlike movies recommendation system, movies recommendation system, web series recommendation system, right? In fact, Insta Reel recommendation system is also a part of unsupervised machine learning, right? Insta Reels, YouTube suggestions, all these comes under the unsupervised machine learning because we are just not having the like X data set. We want to analyze the behavior of the data set, right? We don't have any Y target data set. We just want to understand the behavior of the given features, right? And that makes this as an unsupervised because there is no one to supervise us. We have to supervise us own. That is called self-reliance learning. It's like we have to create our own learning, right? So in this unsupervised learning, we have multiple popular concepts. It's like market basket analysis, customer segmentation, movies recommendation system, web series suggestion, Insta reel suggestions, YouTube video suggestions. All this comes under this unsupervised machine learning, right? Now, how exactly this works? Let me just show this. Suppose we have this the scatter plot, and inside this scatter plot, we have four different candidates, right? Based on their age or not their age, based on their, let me just take the salary and then the spending score and then the salary. Let's just take the salary and the spending score, right? So at this x-axis, it is like the salary, okay? And at this y-axis, we have the spending score, right? Okay. Now, what we want to quickly analyze our customers, right? We have different set of customers now. We could have customer that those are less in salary and they have low spending scores as well. This could be possible candidates. Is that clear, right? These are like my low target customers because they have low salary as well as low spending scores, right? Now, what about this one? These are like my low salary customers, but their spending score is very high. It can be Gen Zs, right? They are not getting enough salary, but their spending score is high. Okay, whatever the like reason could be, but you have to just quickly analyze the patterns, right? What about this one candidate? These are like high salary, but they are having their low spending score. This could be like the mature customers or like old age customers where they are getting the highest salary, but they are not spending that much, right? These are like my higher salary side, but low spending score. And what about this one candidate? These are like my high spending score and high salary. These are like the main target customer that we need to target, right? Can I say this candidates, right? So how do we get to know why we are getting this kind of pattern, right? These are called the unstructured or not the unstructured, it's called like the unsupervised kind of pattern, right? Where no one is telling about that this data belongs to this category. We are just quickly analyzing this data set. And it's like we are just using our own intelligence that makes this as a unsupervised machine learning, right? Let me just quickly convert this scatter plot into some meaningful information. This belongs to low target customer, low spending score, low salary. Okay. And let's just use another color here. This one is like low spending score, low salary, low rated customer. High spending score, but low salary. It's like uh, it can be like the future customers, or it can be like the kind of some sort of targeted customers. You can also refer this as, right? And they are like high salary but low spending score. So these are like the some sort of dormant customer where they are getting higher salary but they are not spending that much enough, right? And these are the main customer or like the prime customer where they have their spending score and the salary structures as well, right? So now if you got any one blank data, and the blank data is like some sort of like this one, okay? You're getting the blind data like this. Okay. Now you want to check exactly which customer group does this data fall. Okay. You have to calculate this one. In the unsupervised machine learning class, we have to create the groups. Okay. In the unsupervised learning, let me just write this. In the unsupervised machine learning, we have to create groups, and sometimes we refer this as groups as clusters, groups or clusters of groups. Okay. And these clusters or groups is responsible for understanding, right? Here we are creating the groups. We are not simply targeting any of the data set. We are just simply checking the pattern. Okay, the density is very much high here, so let's just create a group here. The density is very much higher, let's just again create a group here. Okay, now suppose we are getting one input data set from the market. Okay, and the data set, their correlation of their salary and the spending score, some sort of like this. Now just let me know, candidate, if you are available here, just let me know exactly which group or cluster this new data set belongs to. Just let me know in the message area where exactly this new data set belongs to. Whether it is like, is it belongs to red clusters, green clusters, yellow cluster, or like light blue cluster? Just let me know in the message area, class. The new data set belongs to which clusters? Which you can just simply refer this as cluster or like a group. Anyone wants to say something? Like my new data set exactly belongs to which clusters? So can I just say, I cannot directly say this. See, we have a visual intelligence. So by using that human visual intelligence, I can simply refer this as, okay, because there are some sort of like very less distance here. So let's just say this new data set belongs to this green clusters. Or it's like where the customer, they have low salary but the high spending score. So how did you just calculate this? You have calculated this based on some sort of distance, right? And in the same way that K-means use the approach, how many neighbors or like how many clusters I need to check with, how many data points I need to check with, right? And these are like called the nearest data points. While you are creating the any K-means or any sort of unsupervised machine learning, all these are particularly based on distance-based algorithm. You have to calculate the distance. Let's just pick 5 neighbors or like 5 data points from this one, right? This is the new data set now. Let's just pick 5 data points or like nearest data points. Okay, so it will try to calculate the distance from this one, the first data point. The second point, it will take this one. Okay, the third could be like this one also. Fourth could be, it can be this one also. Okay, and the fifth one is like, let's just take this example. Now you have to calculate the distance of each one. This is like my D1, D2, D3, D4, and the D5. And now just let me know exactly this new data set is closer to which group. And everyone will say, okay, this new data set is closest to this green one now. So let's just consider this new data set as a part of this cluster, because the new data set is closely related to this group or this cluster. That is the reason we are considering this data set as like the low salary and the high spending score, right? So in this way, the K-means actually work. So we have different set of unsupervised machine learning, like the way we have supervised machine learning. So let me just quickly show this list of unsupervised machine learning, and we will start this in next class, right? List of unsupervised machine learning. The very popular one is called the K-means, right? The second one is like the hierarchical clustering, again very easy. Third one is like the DB scan. DB scan is just nothing, it's like the density based. Whenever you are getting the higher density, you can just simply refer this as a DB scan. The fourth one is like the mean shift, and fifth one is very easy, which is like the Gaussian mixture, right? And then we have multiple different clusterings as well, right? But the very popular one are like 3-1 K-means clustering. So the interviewer generally asks you the different clustering algorithm, but generally followed by the K-means clustering, hierarchical clustering, and the DB scan clustering. And all these are very similar. If you're familiar with any of the one, then you can probably calculate the rest of the one, right? Let me just show this. These are the images of all the three like different algorithms that we have. The first one is K-means versus the second one was like hierarchical clustering versus DB scan, right? Okay, just understand this image, and we will try to deeply understand what exactly this image is. The K-means is like we have to shift the mean, we have to calculate the average centroid value, and whatever the data set belongs to average centroid, then we'll particularly consider this as a new group, right? So it's like calculating the mean or like moving the centroid towards the group. Can I just say that the average, let me just increase the size of this marker. The average centroid of this data set, the average centroid is like, it's like the central tendency or like the average centroid. It's like the mean value. It belongs somewhat here. This is the average centroid of this cluster. Same way you can say the average centroid of this cluster belongs to here, and same way like this, and same way like this. Now you have to check the distance from new data set from their nearest centroid. And if you check the distance from the centroid, whatever it is closest to, it will belongs to that cluster. This one is very easy, right? So let's just quickly understand this in the next class, how to implement this k-means algorithm from scratch, or like with the help of some sort of modules. And then we'll probably understand the different set of unsupervised machine learnings as well, right? So guys, this is for the today. And I have few announcement as well. We have to connect tomorrow as well. Let me know how many of you are comfortable with it, right? And the timing will remain is like 5:30 to 6:30. You'll get to know. We'll probably connect around 5:30 in the evening tomorrow, and the duration will be of 1 hour. Okay, we'll cover up the part of this K-means, the practical intuition and the mathematical implementation as well, right? And then Monday onwards, we'll start with the next topic, right? So this is for the today. If you have any queries or any questions, just let me know in the message area, guys. Spurti, Taruna, other candidates, guys, I always insist and suggest to be and to try to be like a two-way communicator, so that if you're not particularly letting me know the issues or like the problem that you are facing, so you're not going to understand the concept very well, right? So you can simply let me know if you are facing any issues or like concern, guys. Okay, so shall we close for the today? I think it's good to go, right? I have already shared my no issues, sir. Okay, got it. Thanks, Purti, right? So okay, sir, if you are going to take class tomorrow, take it at 7 p.m. Okay. See, I'll try, but because the tomorrow is like I have some different schedules as well. If it is possible, so you guys can connect around 5:30 because I have that slot only. Okay. I'll try my best to like be connected 7 p.m. But you'll get to know if it is not available, right? Okay. Most probably we'll connect around 5:30, right? Okay, candidates. So let me just quickly stop the recording. I'll share my GitHub link, the dataset, so that you can practice it, right? And let's just connect tomorrow. Okay, candidates.